Okay. Section 2.2 is going to be over linear equations and solving linear equations and graphing linear equations. So let's first talk about what is a linear equation. A linear equation is some equation that whenever we look at it, you see we have our unknown variable being x has a power of 1, an exponent of 1. That is going to be a linear equation. So when we're going to solve these, there's no like serious tricks or anything we have to do. We just go through and do one-step transformations, get x by itself, and solve it. I'm sure a lot of people are pretty familiar with how to do these. So this is should be a little bit of a review. So first step, we want to get x by itself. So there's several different things you can do to begin to do that. I'm just going to subtract 3x. When we do that, it gives us 2x plus 2 on the left and negative 6 on the right. Subtract 2, get 2x equals negative 8, and divide by 2 gives me negative 4. This is called, whenever we have a single solution like this is called a conditional equation. Conditional. Okay, because the condition for this to work is if x equals negative 4. Anytime we have a solution, it's conditional. There is chances for them to not have a solution and they have other names. Another type we encounter is called inconsistent. Inconsistent. Here's an example of one like that. Say we have 5x minus 15 equals 5x minus 20. If I go to solve this one just like I did the last one, you see the 5x's go away, and I have negative 15 equals negative 20, which we know is not true. So, on this one, we would say it's inconsistent. And that's pretty self-explanatory where that name comes from. It doesn't balance, so it's an inconsistent equation. Another type would look like this. When I go to solve this one the same way, I'd have 3x plus 6 equals 3x plus 6 when I use the distributive property here. And so then if I subtract 3x from both sides, they go away completely. And then if I subtract 6 from both sides, they go away completely as well. So I have 0 equals 0. Now let's look at the difference here. The very first one had one solution. This one has no solution. There's no value for x that would make that equation balance. This one, it's not no solution in this case, because 0 equals 0 is a true statement. Because in this, you can see here, if I go all the way back up to the top, whatever I put in for x, on either side is going to make that balance, because it's the exact same thing. This is referred to as an identity, and it has an infinite amount of solutions. Okay? So, there's the 3 different types we can come across. Now let's look at some different types of rational equations and how we would go about solving them. Let's look at some that contain fractions. Whenever we have fractions, it's really easy to get rid of the fraction if we multiply by the denominator. Because the denominator is division, we can undo division by multiplying by that. Well, in this case, we have multiple fractions, so we want to get rid of all the fractions by multiplying by one thing. So what we want to do is find the least common denominator of those 3 guys, which ends up being 6x. Okay, so it's the least common multiple of all the denominators, or better known as the least common denominator. So if I multiply everything by 6x, it will get rid of the fractions. So on the first one, you see we have 6x on top and 2x on bottom. That leaves me with 3 on top times the 7. On the next one, 6x on top, 3x on bottom leaves me with 2 times the 5. 6x on top, 3 on bottom leaves me with 2x on top times the 22. So over here I have 21 minus 10 equals 44x. So that's 11 equals 44x. Or when I divide by 44, I get 11 over 44, which is just 1/4. Okay? Same technique. Say I have x over x minus 3 equals 5 over x minus 3 minus 1/2. In this case, we have x minus 3 as the denominator and 2 as the denominator, so the least common denominator, the least common multiple of those two, is 2 times x minus 3. So on the first one, or the left-hand side, the x minus 3's cancel, and I'm left with 2x. Right-hand side, first term, the x minus 3's cancel, and I'm left with 5 times 2. And then the second term in the right-hand side, the 2's cancel, and I'm left with minus 1 times x minus 3, or just negative x minus 3. So I have 2x equals 10 minus x plus 3, which is 2x equals 13 minus x, and then I can just add x to both sides. 3x equals 13, or x equals 13 over 3. Okay. One more example with the fractions. Excuse me. Let's do 2 over x plus 1 minus 1 over x minus 1 equals 2x over x squared minus 1. Okay, so when I do this one, if you look at this guy, that is the same thing as x plus 1 times x minus 1. No, it's the difference of squares if you factor it, or you can multiply those two sides together and see it's x squared minus 1. So, knowing that, you can see that the least common multiple is just going to be x squared minus 1. So, right hand side cancels completely and I'm left with just the top. Left hand side, since we know that, let me make a little note down here. Since I know that x squared minus 1 is x plus 1 times x minus 1, first one, we're going to end up with the top part. Take that off here. I'm going to end up with 2 times x minus 1, because the x plus 1's cancel. Then I'm going to have minus 1 times x plus 1. Okay, so then whenever I clear all that out, let me get this out of the way. Start combining like terms. I have 2x minus 2 minus x minus 1 equals 2x. So that gives me x minus 3 equals 2x. And I can just subtract x from both sides. I get x equals negative 3. Okay, I'm going to stop there for the first video of 2.2 and come back with graphing.